morning all. Continuation of the lecture series. In today's session, we are going to discuss about the scalar quantity, few examples describing the scalar quantity and vectors. Physical quantity with magnitude and no direction is represented as a scalar quantity. Some physical quantities can be described just by the numerical value with their respective units. For example, rupees 10,000 or 5 centimeters without representing the directions. They do not have any directions. So some examples of scalar quantities are mass, speed, distance, time, area, volume, density and temperature. So we know what mass is. That is a weight of any element. For example, weight of a watermelon or a fruit. For example, it may be around 1 kg or 3 kg. Next is speed. The speed at which the car moves. It is 60 km per hour on a highway. Next is the distance and the length of the road. It is 100-meter length. And the time, the duration of travel is 3 hours. And area, the surface area of the house is so much meter square. And the volume, the amount of milk what we buy is in terms of volume. And density, the thickness of any element or a material. The density of a gold is so and so. And temperature, the body temperature of a healthy human is 37 degrees C. Likewise. So these are some scalar quantity which is not dependent on the direction. Next is a vector quantity, vector analysis. So physical quantities which can be represented along with the direction can be simply named as a vector quantity. It has both their magnitude and direction. Some vectors are zero vector, position vector, like and unlike vectors, collinear vector, displacement vector, unit vector, co-initial vector, coplanar vector, equal vector, negative of a vector, and many more. So let us understand each of them with an example. So zero vector means if an object is placed in one particular position, means there is no displacement, hence it can be called as zero vector. For example, a car is parked in the same place, has zero displacement, meaning its displacement vector is a zero vector. If we represent in a coordinate system, 0, 0, 0 means in x direction, in y direction and in z direction there is no change in the displacement. Therefore, it is a zero vector. Next is position vector. The GPS coordinates of a moving vehicle related to a fixed reference point on a map is nothing but position vector. For example, if we switch on our location in our mobile, we can see the movement, our movement. We are moving from this place to the next place. So this is the position vector. Next is like and unlike vectors. We know like it is similar, unlike dissimilar. So if we consider two people moving an object like pushing a table in the same direction, so both are moving towards the same direction in x direction, means it is like vectors. If the two people move the door in opposite, one is pushing and another one is pulling, means they are moving in the opposite directions, those are considered as unlike vectors. Next is collinear vector. Collinear means two which is moving the parallel tracks, parallel to each other. Then we term it as collinear. Two trains moving on parallel tracks in the opposite direction are collinear to each other. So two trains, one train moves on one direction, on their parallel paths, another train is moving on the other direction in the parallel paths. So those two are collinear vectors. Next is displacement vector. A person walking from one place to another. For example, if I am going for shopping, I am moving from my home to the shop. So that is nothing but a displacement vector. A person walking from home to a store. The vector represents the shortest straight line distance. Next is unit vector. The direction of airflow in weather map is represented by unit vectors of wind velocity. Next is co-initial vector. Two forces acting on the hanging object from the same point. For example, if we hang a string, then based on the forces, external forces, the string will move here and there. That is nothing but co-initial vector. Coplanar vector. Forces acting on a book lying on the table. Gravitational force, normal force, friction. So it is a vector which acts on a plane surface. If we place anything on the table, so the force that gets acted on the table is gravitational force, normal force and friction. That kind of vector is named as coplanar vector. Next is equal vectors. Two cars moving at the same speed in the same direction have equal velocity. Same speed means obviously it will be in the equal velocity. That is named as equal vector. Two identical cars moving at the same speed in the same direction have equal velocity vectors. That is called as equal vectors. Negative of a vector. A plane flying north and another flying south at the same speed. That is nothing but negative of a vector. So hope you understand all these examples, right? So next is examples of vector quantities. What are the examples? So linear momentum. We know what a momentum is. That is, momentum completely depends upon the mass of an object. For example, a moving truck has more momentum than a bicycle. We can understand the structure of bicycle and a truck. Bicycle is very small and the truck is huge in size. So the moving truck will be having more momentum than a bicycle. The momentum completely depends upon the mass of an object. Right? Next is acceleration. A car, acceleration is nothing but it refers to the speed. A car increasing its speed from 0 to 60 kilometer per hour in 5 seconds is nothing but acceleration. We obviously mention accelerate, which is nothing but increasing the speed. Next is displacement. Moving from one point to another is displacement. As we walk from our home to the shop or nearby railway station, it is nothing but displacement. Next is momentum. Momentum is nothing but simply moving or pushing an object at higher speed. For example, a football kicked at high speed has momentum due to velocity and mass. Even though the ball is of small in size and of lighter in weight, because of the uh, push applied, it gains higher momentum due to that velocity and mass. Next is angular velocity. The rotating hands of a clock exhibit angular velocity. Yes, um, we may imagine a clock. It has a short hand and long hand. So that exhibits angular velocity as they move around the clock face. Next is force. Pushing a cart or a sledge so as to make it move, applying some force to make it move from its initial position. Next is electric field. A charged balloon attracting small paper pieces due to its electric field. Even uh, we might have heard about a comb attracts some pieces of paper. All these are due to electric field. Next is polarization. The best example for understanding the polarization is sunglasses. People wear sunglasses so as to um, block specific light waves, as to reduce the glare. Sunglasses obviously reduces glare by blocking specific polarized light waves. So this is an example for polarization. So next is unit vector. Unit vector, as the name implies, the vector has a magnitude of 1. Suppose if x is a vector having a magnitude, then the unit vector is denoted by x cap, which is in the direction of the vector x, and also magnitude is equal to 1. Specifically, unit vectors is used to indicate the direction of the vector quantity, right? As given here, x cap is equal to vector x divided by magnitude x. So everywhere in this drawing, so everywhere in the x-axis, the red indicates the unit vector. In the y-axis also the red indicates the unit vector, and in z-axis the red arrow indicates the unit vector. Unit vector simply represents the direction of the vector, whereas its magnitude is always 1. Position vector. We have discussed this already. That is, if a person or if an object moves from its initial position to some distance, then that is named as position vector. For example, if O is as the reference origin point and P is some other point in space, then OP is called as the position vector of that point. Position vector simply denotes the location of the point in the three-dimensional system with respect to the origin. Properties of vectors. The important properties of vectors shall be explained with three different vectors A, B and C, and the quantities are m and n, where those two are scalar respectively. Addition property. A plus B equal to B plus A, that is nothing but commutative law, means the order in which the variables or vectors are added is independent. It gives the similar value. A plus B is equal to B plus A. Next is A plus B plus C is equal to A plus B plus C. This is associative law. This also emphasizes the same concept. Even though the order of the addition of the vectors are changed, the result is same. Next property is subtraction. Subtraction means A minus B, which is equal to A plus of minus B. This clearly says that the subtraction of the vectors is easily obtained through addition principle. The third property is multiplication by a scalar. As mentioned now, m and n are the scalar quantities. So m into a is equal to a into m. Again, commutative law has been satisfied. And also, if the vector is multiplied by two different scalars, like m of na is equal to n into ma. even if the scalar quantity is portion of the scalar quantity is changed, the product is similar. Distributive law, m plus n into a is equal to ma plus na. M of a plus b is equal to ma plus mb. So these are the multiplicative properties of vectors. A quotient vector is represented graphically by a directed line segment. A unit vector is a vector of unit magnitude directed along that vector. So small vector small a cap is the unit vector along the direction of a. So this is the graphical representation of vector A. You shall represent as vector A or unit vector A. Both the representations are right. Whereas the unit vector is equal to small a cap is equal to vector A divided by magnitude of A, or A is equal to unit vector into magnitude of A. So the product of two or more vectors. How shall we analyze if we have more vectors and how to conclude the product? The product can be taken in two forms. One is scalar product, another one is vector product. Scalar product is otherwise named as dot product. It is represented as A dot B, which is equal to magnitude of A, magnitude of B, cos theta. Next is cross product. Cross product, it is otherwise called as vector product, where C is equal to A cross B, which is equal to magnitude A, magnitude B and sine theta, where theta is the angle between A and B. And A is the unit vector perpendicular to the plane A and B, directed such that A, B, C form a right-handed system of the vectors. So whereas the cross product vectors do not obey the commutative property, A cross B is equal to minus B cross A. And here also A cross B plus C is equal to A cross B plus A cross C. So these are the important properties of vectors to be remembered while solving the problems. Hope you understood this session. Thank you for listening. Thank you.